Hello, I'm from Keeling Walker in the United Kingdom and from Thermox Performance Materials in Germany, and we are a manufacturer of functional pigments. Our purpose to be here on the Nanotech show is to demonstrate the performance of our near-infrared absorbing and laser active substances. Primarily we produce pigments in a powder form, so light-colored or dark-colored inorganic pigments, which means that they are environmentally friendly and thermally very stable. However, in the application, they are not only used as powders, but also in other forms. The typical idea of an infrared absorbing material is that it provides transparency in the visible range and absorbs the part of the sunlight which is not visible, which is the infrared part. Typical applications for these types of products are solar protection window films, which are popular used in automotive applications, in residential applications, and for a couple of others. Typically, these films are composite materials, multi-layer systems, and in order to provide good transparency, you need to have very small particle sizes, typically below 100 nanometers. And that is what we manufacture, either as a liquid dispersion or in form of a master batch, which can be directly incorporated into the polymer. Or we can have it as injection molded parts for glazing applications for residential building coverings, for greenhouse applications, and similar areas where solar protection is needed. There are different types of NIR absorbers available, which largely differentiate themselves by the type of performance. They are cost-effective materials, they are low-colored materials, and there are obviously high-performance additives which cut out everything. The low-color materials are interesting where any color is a disturbance to the aesthetic or other performance-based materials or based applications. Whereas when high performance is needed, you can afford a higher color, which obviously is visible, and which also adds in the automotive, for example, the effect of increased privacy in the passenger area. Other applications include, for example, laser marking additives, which are also based on near-infrared absorbing materials. The laser light is converted into heat, and the heat generates the black marks on the polymer. And wherever a durable, non-destructible marking is required, which survives long time in harsh environments, laser marking is the superior choice over printing applications, for example, or other types of marking, because even after many years of usage, the laser marking will be still visible and readable. The products are made again as powders or as master batches for direct use in the polymer industry.